So what are the features of stacks? So in a stack, items are added to the top of a pile. So for example, if we put A into this small array, it gets added to the bottom of the pile because there's nothing else. But when we want to add another item, B, it gets added on top of the A. When we add a third item, C, it goes in at the top of the pile. And conversely, when we remove an item, items are removed from the top of the pile, so the C comes out first, and then it's removed from the stack, and we can process that item, and then next the B comes out from the top of the stack and it can be processed. And lastly, if A is the last item in the stack, then it comes out and we can process A. And so this is known as something called last in, first out method. Now we've also got some key terms when we deal with stacks. So when you're adding an item to the top of a pile, what you're doing is you are pushing an item onto the pile. And when we're removing items from the top of the pile, it's called pop. Okay, so we push an item onto a stack and we pop an item from the stack. Let's see this in an algorithm. So let's take a look at the pseudocode implementation of the stack. So we need two variables called base position and top position to store the bottom and the top array position of the stack. We need an array itself. There's an array of 9 characters. And pushing is a procedure. So we push the item into the stack. So we increment top position by 1. And then we set the stack at position top position to be equal to the item that's been passed into procedure. For a function, because we're returning a value, we're going to return a character. So we take the stack, and it's only we don't care about the item or the number because it's just merely giving us the top item on the stack. So we'll create an internal local variable. We set that output variable to hold the value of stack at the top position. We then decrement top position by 1, and then we return the character from the top of the stack to the calling code, and that's the end of our function. Now obviously you can add some error checking in here, so you can't push if you've reached the limit of the stack. So for example, if you know that top position is already at position 8 in the array, you wouldn't go above it. Similarly, if you're pushing, you would check to make sure that top position won't go below 0, because again that would cause a catastrophic failure in your program. So you can add error checking, but we haven't written it here. So I'd like to talk through a worked example for a trace table. So first of all, we create the stack. Okay, and so this is our trace table and this is the stack. We're going to push T onto the stack, which increments top position by 1. And we're going to push A onto the stack, which increments top position by 1. And then we're going to pop the item from the stack, which reduces top position by 1 and outputs A. And then lastly, we're going to push item I onto the stack. And so that puts the letter I at position 1, which is top position, and then increments it by 1. And because we're pushing, there's no output. And essentially, that's a very quick worked example showing how how the pseudocode would be executed in the program. So let's finish thinking about when are stacks useful, and you can use them when you're reversing the order of a string, for example, or a word. You can also use them to remember paths to a file or folder, the different folders and drives you have to go through. You can also use stacks when you're generating directions from a start point up to a destination. And lastly, stacks are useful when you're working out the best move in a computer game. But these 4 methods are just a small sample of how stacks can be useful in your computer programs.